Hey, I'm muted. Yeah, I was muted. Hey, Kinky, how are ya? Yep. Can you hear? Can you hear? Check, check, 1, 2. Mic check, 1, 2. Audio check, video check. Okay. Yeah, I was muted. The reason why I was muted it was when we did the video last week. Had to mute. Yeah. Okay. Hey, rich man, poor man, how are ya? Hey, vibes. Good. All right. Hello, everyone. Welcome to Episode 5, Season 5 of Introduction to Security at Tufts. I'm Ming Chow, Associate Teaching Professor, yada, yada, yada. Um, October is National Cybersecurity Awareness Month. October is also Breast Cancer Awareness Month. Right? One of the reasons why I enjoy teaching the security course in the fall semester is because of National Cybersecurity Awareness Month. Um, since I taught this course since fall 2013, um, there's always been a password competition starting at the very beginning of October that lasts for the entire month. Also, for the security class, students play capture the flags near the end of the month as well too. Historically speaking, National Cybersecurity Awareness Month is also a time of a lot of hijinks that happens around the world with regard to technology. Okay, and today's topic is going to be passwords and password cracking. All right, so I'm going to do an example to start off. So imagine that we have a database table of users. Okay, now this is a database table of users. Now, what a database, if you don't know what a database is just is a massive collection of records. Okay, um, a lot of databases will have what is called a users table, a list of uh, people, first name, last name, username, email addresses. Ads. Now you gotta sign in. Dude, you gotta sign in. If you don't have are you signed in? Interesting. Interesting. Anyway, so imagine that we have a database table of users that contain the following fields: some sequential ID, username, and the password. There you go. Now an ID is just going to be a number. And I'm actually going to use usernames from followers. Really? That is so messed up. I think you've just signed in. I mean, well, then again, the reason why you're getting ads is because, well, I am an affiliate and I made no money from this damn. I made no money from this thing. Anyway, sorry about that. Pain in the ass, too. Really? Yeah. Okay, I'm gonna do C Pinky. Hey, Oblivion, how are ya? Okay, I'm gonna have another user. I'm gonna Oblivioner. I have you in here. This is gonna be a fictitious example of username. Rich man, poor man. Let's do a big username. Rich man, poor man fan. There you go. Yeah. So I'm gonna have a database table here. This is fictitious, of course, but to illustrate the problems. I'm gonna add one more. I'm gonna add one more user. I'm gonna have Vibes. How about Vibes? You're listening in. Hey, one of the rewards of tuning in on this Twitch session is you get noted. You get named. Yeah, you get using an example here. And zip flyer. I got a zip flyer too. Alright. No zip flyer is on. Cool. So this is a fictitious table of users, and I'm going to give each and every one of these. Now I have 6 users here. Noah Turv, C Pinky 12, Oblivioner, Rich Man, Poor Man Fan, Vibes 28, and Zip Flyer 1. Alright, fine. Fine, okay, fine. I'll do slap cake. Alright. Your password is going to be poop. That's it. No, your password is going to be poop. And I'm going to make something up. Okay? Noah, your password is going to be Harry 12. Okay? Zip flyer, I'm going to see TB12 LFG. Okay? See Pinky, I'm going to make your password. I'm going to make something for that. Pinky swear. I'm just making stuff up. Okay? Oblivioner, your password is going to be, well, we'll just do one of the worst ones in the world. ABC123. By 28, it's also going to have the dubious distinction. You're going to have the user and the password ABC123. And Rich Man, Poor Man Fan, I'm actually going to give you the biggest, the best password in the world. Money is the most important thing in the world. There you go. You want to change the password to password, Noah? Okay, fine. Alright. So here it is. So now we have a table. We have a table of users. This table will have 3 fields currently. ID, username, password. Now, when you're designing databases, one of the things that you have to keep in mind is, especially these days, everything gets hacked these days. You want to make an assumption that, well, you always want to prepare for the worst case scenario, which is your database will be popped or broken into or stolen or leaked out and all that fun. Okay. So, and here we are. That being said, let's make an assumption that this database table got stolen. This got leaked to the world, as is. All of this information got leaked out to the world. Okay, so now, with all these lists of username and password leaked out to the world, what's the problem? Come on, as is. If you're taking a look at this entire screen right now, I hope you can all see. If this gets leaked out to the entire world, okay, somehow this database table got leaked out to the world, or you're seeing it right now, what's the problem? I mean, there's one very obvious problem. The username is stored as is, and the password is stored as is. Also the ID. Okay? Now, it's not that you can't use those passwords anymore. Well, okay, yeah, but of course, alright, fine. Rich Man, Poor Man Fan, you're correct. Of course you can't actually use those passwords anymore, but there's of course another reason. Why can't you use those passwords anymore? Yeah, Zipflyer once said, well, unfortunately, it boils down to one word. Yeah, Elite Particle said, you got owned. But actually, it's not even that, it's that you look like a fool. Because now the attacker said, oh my god, I got all this username and passwords. Oh, this is great. I don't need to do anything because everything was stored in plain text. That's the problem. Okay, ZipFlyer1 basically said the point. It's easy to read the username and password because, of course, everything is stored in plain text. You never ever want to store, if you're writing system, when you're building system, you never want to store, you never want to store, especially the password, in plain text. You never want to do that. Unfortunately here, all the passwords are written in plain text. Okay? So, this is just really bad design. On a scale of 1 to 5, like a 5 alarm, where 5 is like catastrophically bad, this is a 6. Oblivion. Let's get to that. That's the point later on. How does Linux stores it? We'll get to that in a few minutes. Please ask that question again, maybe in 30 minutes. Okay. So is there a way that we can improve the design of this users table and not store the password as plain text? And the answer is yes. Let's do a step up. Let's do a better design, but not the end all be all, because it also has a serious problem. Now I want to introduce you to the idea of one-way hash functions. Cryptographic one-way hash functions are, well, here's how a cryptographic one-way hash function works. A cryptographic one-way hash function, it takes in a string or binary, it takes in data. Okay, it takes in data. I'll just open a new tab. Why not? I just open a new tab. Hash functions. Okay, hash functions. That looks ugly. Let's not save that. Come on, I want a brand new text file. There you go. Okay. Cryptographic hash functions. Okay. They are one way. Okay. No decryption. Okay. Now how it works. Something like function takes some data, output key, block. I would allow that. Fine. So a quick hash function, the idea is simple. You take in a hash function takes in some data, and it'll generate some output. But here's some properties, some very important properties of hash functions. Okay, there are 4 of them. One way. Not reversible. Well, no decryption. No function to decrypt or reverse. It's only one way. Only one way. The other way is very important thing. The other important property of good hash functions, no collisions. Okay, if you have 2 different data, okay, if you feed in 2 different sets, 2 unique data to the function, you don't get the same output. That will be really bad. That will be really bad. We'll get to that in a few moments too. The other one is reproducible. Think I spelled that right? Reproducible. That means, okay, I don't care whether it is on C. Pinky's computer, Vibe 28's computer, Slapcake's computer. It doesn't matter what computer you're on. It doesn't matter what day or what time it is. Okay, you feed in a particular data to a function, you'll always get the same output every single time. Okay, and one more, uniform distribution. There's going to be some uniform distribution, randomness. Because you don't want the things to be too damn predictable either. Because you don't want the output to be too predictable. That kind of that's not a good idea. Some real world examples. MD5, SHA-1, SHA-256, SHA-512. There's a whole list of them. There's so many different examples of hash functions. Now, let's do a real example. And this is website, md5calc.com, that actually you can play around with all the different hash functions, okay? And the algorithm that we're going to use, we're not going to use MD5. Let's use SHA-1. And the string we're first of all going to encode, okay, So here's a lot of, remember these real examples? MD5, SHA-1, SHA-256, SHA-512. MD5, yep, SHA-1, SHA-256, 384. There's also 512 as well. There's a whole bunch of other ones. But we're going to use SHA-1 we're going to use SHA-1. Okay? And now, instead of storing the actual plain text password, we'll just store, boom, the hash value. So the SHA-1 of the string password is that. So instead of storing plain text password with a capital P, we store the hash value of the string password. Do it again. Pinky swear for C Pinky 12. All right. And we got the output. The SHA-1 of Pinky swear is 199 yada 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 F all the way to B4. So instead of Pinky swear, we have that. Now we have ABC 1, 2, 3. Oh, by the way, if you're curious, is it case sensitive? Let's do Pinky swear with a little s, see what happens. Yeah. What happens if you add a number 1 to Pinky swear? Pinky swear 1. Will the hash value change? The answer is yes, of course. Let's do what's the SHA-1 of ABC 1, 2, 3. There we go. But I'm going to cheat a little bit because we know Vive 28 password is also ABC 1, 2, 3. Rich man, poor man, fan. Your password, this long, big ass string. The SHA-1 of money is the most important thing in the world is, okay, F8, all that. Zip flyer 1. Your hash value of TB12LFG, all in caps. And let's do one more. Oh, poop. Hey. All right. So now, what we just did, we just calculated the SHA-1 hash value of all the plain text passwords that were originally here. How does SHA-1, okay, how does SHA-1 work? Can two different passwords come out with the same? No, okay. RZ2750. Okay, how does SHA-1 work? Well, a lot of math. How does SHA-1 work? There's a video on here. There's a video. Here's the pseudocode of SHA-1. Pseudocode of the for the SHA-1 algorithm goes like this, publicly available. All the code for the hash function that we use in the world, all publicly available. Here it is. Initialize variables, pre-processing, process a message in successive 512-bit chunks. Here's the code. This is literally it. This is literally the code to generate SHA-1. Okay, but here is, okay, so RZ2750, I don't know if there's a way I can award, or give awards out. Yeah, second question, can two different passwords come out to the same hash value? Well, here's the thing, remember what I wrote earlier about cryptographic hash functions. You don't want collisions. Collisions are really bad. So ideally, the answer is, can two different passwords come out with the same hash? And the answer is, well, unfortunately, well, in a perfect world, the answer is you don't want that. You really don't want that. But let's get to that in a few seconds. What are some of the problems? Okay, this is this table that we just did. With using it now, we have, instead of storing the plain text password, we store the um, SHA-1 hash value of the password. So this is a lot nicer that we are not actually, we're not showing plain text passwords anymore. But what are the problems? What are the problems? There's still some major problems with just storing just the cryptographic hash value. What are they? There's two of them I can think of right off the top of my head. Okay, so Tycho actually had a great answer. Collisions are very unlikely in the real world. That's really the best answer, but theoretically possible. You can just brute force and come out with a stored value. Okay. RZ2750 actually mentioned a very important point. Unfortunately, there's three. Okay, first of all, can't you just test all the digits of the hash because they all have the same digit? Yeah, good luck with that, though. But RZ2750 said a very important point, which is a one big problem. Looks like two people with the same password have the same hash. Look like Oblivion and Vibe 28. Your hash values are the same. Your password are the same hash value as is seen here. That also means that you're both using the same password. So that's problem number one. If we're just storing the plain hash value, the straight hash value of the plain text password, that's not good. Because now we still have the problem that we can deduce that Oblivion and Vibe 28, you're both using the same password. You both have the same password. We know that. Um, well, the other thing is, the second big problem is, you, it's not really brute force, but it's on that road. So nowhere you can just brute force and check if the answer comes out the stored value. Okay, so here's the thing. Ideally, remember what I said about hash function. Hash functions are one way. There's no function to decrypt or reverse. So there's no way, no function out there that can take, there's no function, no decrypt function that can take a hash value, such as this, and then you'll get back whatever the original plain text was, which I believe was ABC123. But here's the thing. People around the world have already calculated the hash values of all the major passwords and major dictionary words. So if you actually want to quote unquote reverse, or actually want to actually identify what the original plain text of a hash value is, especially when it's SHA-1, you can do so. So for example, if I take Slapcake, let me take this the SHA-1 hash value of your password. I'm just gonna do a Google search. My mouse is all screwed up today. I'm just gonna do a Google search. Go to google.com. And I'm just gonna do a search for that hash value. And let's see what we get. Here you go. Here you go. Someone has already calculated the SHA-1, the hash values of all the major dictionary words, all the commonly used passwords. So if I do a reverse of if I do a Google search of the SHA-1 hash value to start with 81B to 7BE, looks like it's poop. Mm-hmm. Okay. What about this one? How about this password? How about this hash value? 6367 yada yada yada. We do a Google search on that. Can we find anything? Oh yeah. Take a look at the results. Just take a look at the results. I mean, it's there. How about this one? I know Zip Flyer. Let's take a look at this hash value. Is there anything? Have they cracked this one yet in the world? Ooh, you got lucky Vibe 12. Look like 1F4, 1F24, yada yada B6. No one has calculated that. Not find anything. Okay. So Problem number 2 is dictionary words, plain text dictionary words, and the most commonly used password. People already calculated the SHA-1, SHA-256, SHA-512, MD5 hash values of those items. So you can now easily just Google the hash value, the straight hash value, and you'll find, well, what the input was. But there's a third item. So hold on. Tithanus. You ideally said that collisions are very unlikely in real, but theoretically possible. Remember what hash function we've been using. Remember the hash function that we've been using to calculate, to store the hash values. We've been using SHA-1. A few years ago, SHA-1 was broken by Google. And here you go, called Shattered. Shattered.io. Oh, God, okay, hold on. Let me get to that question. Let me show it. So SHA-1 is broken by Google. I forgot what year it was. The industry cryptographic hash function that's used for digital signatures and file integrity purposes and protects a wide range of spectrum analysis, including credit card transaction, yada yada. It's now practically possible to craft 2 colliding PDF files and obtain a SHA-1 digital signature on the first PDF file, which can be also abused as a valid signature on the second PDF file. And this is, there you go. Here's the attack proof. Whoa. Here's the attack proof. It's like tiny here. There? No, I don't. I actually want to see it. So it's like really tiny here. So 2 differing PDF files, 1.pdf, 2.pdf. But they actually got the same. Oh. It's like, what? There you go. 1.pdf, 2.pdf, tiny here, but they share the same hash value. So you have a collision here. So that means SHA-1 is broken. Once you have one collision, it's broken. And here is the infographic. It's like, this is what you're supposed to have. I mean, we've been doing this. It's like if you have a good doc and a bad doc, but they share the same hash value, not good. Who uses SHA? Who used SHA-1? If you use Git, the commit message IDs, the commit IDs, that was all SHA-1 for years. A lot of backup system, document signature system, but the complexity is huge. MD5 was broken a long time ago. So your defense is really use SHA-256 or SHA-3 as a replacement. Yeah. So that's the third item. That's what we've been doing is. So there's 3 really bad reasons why you don't want to store just a straight hash. Well, number 1, you can identify who is using the same password. Number 2, well, a lot of like the common dictionary words and common password, people already calculated the hash values of them already. And number 3, it depends what algorithm that you're using. We're using SHA-1 in this case. SHA-1 was broken already. Why is SHA-1 considered unusable because of one collision? Okay, that's a little bit of a more trickier question. Here's the thing. Although SHA-1 is considered unusable, yeah, I mean, once you have one collision, that means it's quote-unquote no longer safe. But people are still going to use it because it's still very rare. They found one collision. So unfortunately, once you have one collision, I mean, it's not good enough anymore. Okay, but people are going to still use it because of things like, well, legacy system is fast. Okay, so to answer your question, Sam, like SHA-1 is still used, but is it the most secure anymore? No, not anymore. So I hope that answers your question. And so SHA-1 it's not unusable. You can still use SHA-1. It's deprecated, and the reason being is it's no longer that secure because of that one collision. Alright, Geo. Geo. Why is it usually recommended and required to have numbers and special characters, uppercase letters, if they're all... Okay, I'll get to that one in a few minutes. Geo, Geo 26. That will be another... Well, I'll mention that today. Okay, so I have to answer the password complexity question. Okay, and also... how does Linux store? That's going to be coming up next. So how does Linux really store password? I'll just give you an idea, and then we'll actually do a real example of how passwords are stored in a Linux system. So what I'm going to do here is I'm actually going to go all the way back, and now I'm just going to go back to square one. So you now know that storing the straight hash value of the password is not good. So is there another way is there a better way to store password? The answer is yeah, and here's like the gold standard. This is what is currently used in modern systems these days. What if you did this? What if instead of just doing a straight hash of the password, we also store something called a token of some sort? A token of some sort. Now, I'm going to rename the token to be something else. Each and every person here is going to get a token of some sort. That is a random in this case, the token is a random 2 characters. BD, AC, I'm going to do something random. ZZ, hey, it's random enough. XU, okay, IO, MT. Again, the token is random. And also HE. Alright, fine. Alright, so Slapcake, your question is, does it mean that you can somehow craft a collision for someone's password national or that that discovered file has a possible collusion? Yeah, I mean now it is possible that you can craft a collision for someone else's password in SHA-1 because they already did that for 2 different files. But good luck with that. It'll take a very long time to do. Okay, so here it is. This is a random token that I just generated. 2-character token that I generated for all 7 users. For Noah, for C Pinky of Libner, Rich Man Poor Man Fan, Vibe 28, Zip Flyer 1, and Slapcake. Now, what is the purpose of this token? Is this token will be appended to the end of the plain text password. And then what happens is that the password will be hashed with, well, do you want to use SHA-1 again? We can use SHA-1 again. Well, it's kind of bad form, so let's do SHA-512. Okay, let's do SHA-512 now. Okay? Because we don't want to we could reuse SHA-1 if we want, but now you learn that SHA-1 is like shattered. It's been broken. So let's use SHA-512 now. 512 has a longer key. But now, instead of just calculating and storing the straight hash value of the plain text password, we'll also append the token to the end of it. So we're going to do SHA-512. So I'm going to do password, and what is the token for Noah? BD. Okay. There you go. Pinky swear is AC. So we just add rend now pinky swear AC. ABC123, we're going to add ZZ to the end of yours. Yeah, you're gonna get a very good idea. This is a very good idea of how Linux stores your password. Money is the most important thing in the world is XU. Oh, damn. ABC123 again, but this time the token is IO. TB12LFG is MT. And poop HE. Poopy. There you go. So now we have a brand new password. We have a brand new users table. You see token and you see password hash. So now, all right, can we actually tell if two users actually have the same have the same password? No, no more. Okay. What's the importance of the numbers after SHA? That's a good question, Drew Fish. Key size. Okay. SHA-1 is shorter than SHA-256 is shorter than SHA-512. Think of the numbers complexity strength. So now, this is great. This is great now. This is good. We store this token. Thanks to the token, it actually made the hash look way more random. Or the password hash look way more random. There is a more formal term for this random two-letter token that I'm using. It's not called a token. The real world is called a password salt. A password salt is to add randomness to the hashing process. Okay, so how modern systems actually now store password hashes, it stores two things: the actual password hash and the salt. Yeah. So now there's a nice Stack Overflow post I'd like to share with people. Salting 101. Okay. Salt is combined, here it is. Can someone tell me how salting works? So far I understand. Validating password, generating understanding, hash, yada, yada, yada. Okay, so here's the thing. Salt is a combination, is combined with the password before hashing. The password and salt clear values are concatenated and the resulting string is hashed. This guarantees that even if two people were having the same path, the salt is then stored in original clear format with the hash result. Then if you want to verify the password, you will do the original process again. I'm going to make a copy of this. I'm going to send it to you. So let's say, for example, I'm trying to verify the password for Slapcake. So Slapcake, I know that your password is poop, but what happens if you misspell it? So here's the hash value of your password, but I also know yourself. So let's say you type in onto your, let's say, your password field on your web form, on a web form. So B4, okay, E1. So you type POOP, okay, and then the back end, and on the back end, what it will do is just, okay, I know your password salt is HE, so I'll just add the HE, none of it, encode it, and I got 06 yada 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 BE8. Does this match the hash value of what's stored on the date? Nope. Nope. B4 D1. Nah, that doesn't match. What happened if you actually type in your, oh god, let's say for example now, you type in your real password, and you type in, so now in the back end is, okay, we're going to append the password salt to the end of whatever you inputted in, and you get that. B4, yada yada yada, D1. Does it match? We got a match? Yep, we do. So that's how they do verification. Okay, and that's why the salt is important, because salt adds randomness to your hashes. Okay, So the important things that you have to know are now password hash functions and the password salt. Those are currently used and stored on systems these days. All right. And so that now brings up a question. Did I miss anything here from the post? Okay, so for example, yada 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 yada. All right, all right. Yep. The purpose of the salt is also defeating a dictionary attack. Well, we actually did a dictionary attack earlier on. I mean, we can just look up the hash value of certain things and we can just get it back. So that's what a dictionary attack is. A dictionary attack is just look up the hash value, unsalted, and see if it matches anything that has been calculated in the past. Okay, so now you know about password hashing and salting. Now we get the two big questions that we got. The first big question is, Oblivioner, you're there. Oblivioner, your question on how does Linux do it? Okay. Are we ready? So now the big question. I'm going to log into a Linux system myself. And y'all see? I'm going to log into a Linux system. And I am going to create 3 users. I'm going to create 3 users with 3 different passwords. Sudo add user Oblivioner. Wait, did I spell the damn thing right? I'm going to add Oblivioner to my system. Yeah, real production system. Oblivion. And yeah, and now I'm going to give you a password. You ready? Oblivioner. What do you think your password is? May be able to count the number of characters because I banged my keyboard. Yeah. Who else? Who else wants to have a username on the system? Come on, someone chime in. Who also wants a password on this? One of my users, one of the audience members here. Come on, chime in. Hopefully the stream is not dead. Come on. Ooh, okay. Oh, okay. I like this one. I'm gonna go. Your password is going to be. Hey, Royce, is that you? Tycho, are you Royce? No, it's not poop. I just gave you a... Yeah. Hey, man! How are ya? Thanks so much for joining in. Oh, my! Royce Williams, Information Security Specialist, and you are one of the big experts and huge contributors of password and password cracking. We see you all the time on GitHub. Not poop, too. Thank you so much for tuning in. Ah, yes. Thanks for the vocab clarification. Yes. Thank you so much. Means a lot to me that you're here. And I'm going to do one more. I'm going to add magnolia flower. Magnolia flower. You're going to have a password as well, too. Oh, shoot. Yeah, I want to try again. All right. So how many users did I just create? No. I want you to crash. This is awesome. So again, I mean, this is living proof that, you don't know who is actually on. No, this is fantastic because especially 18 to 22-year-olds don't actually realize that there are actually professionals who are actually listening in on this. It means a hell of a lot to me that you're here. So much. Thank you. Wow, this means a lot. Thanks, Royce. Awesome. So now I created 3 users on this system. I created 3 users. Magnolia Flower, Akalabib, and Oblivioner. All right. I'm going to clear the screen. So now how does Linux store your passwords? Your modern Linux system stores a password at 2 extremely important files. They're both in the etc directory. They're both in the /etc directory. The /etc directory is pretty big, but there are 2 files of interest. I don't like this. I don't think you can see. Sorry. Okay, the first file is called Password. Passwd. MorepAsswd. There you go. This is the first file that is extremely important. Here you go. As you can see here, I have Oblivioner, Akalabib, and Magnolia _flower as a user. They're all on here. Yeah, I'm doing this on my DNS black hole. Yeah, I am. All right. What the hell? Well, there's your username and passwords. Come on. That's what's wrong with you. You may be wondering, wait, okay, this is nice, but where the hell is the password hash? All right. So back in the heydays, we're talking about like early 2000s, everything was stored in one file, /etc/passwd. Okay? I mean, this was how it was done in the days. But however, that's not a good idea when you have a single point of failure. But then again, the system needs this /etc/password file for all kind of different purposes. So what they decided to do a little bit later on was to separate out the password hash into a different file. That file is also in /etc, and that's called a shadow file. Okay. If I do, hold on. If I do man, I'm going to clear my screen. I do man shadow. A shadow password file. A shadow is a file which contains the password information for the system account and optional aging information. This file must not be readable by regular users if password security is to be maintained. Okay. So here, where is this shadow file? It's also in /etc, so I can do more shadow. Permission now because you have to have temporary root. Sudo more shadow. And here you go. Now you can see the username. This $6 yada yada. What? Ooh, that looks like a password hash of some sort. Alright. Alright, so how do we decipher that? So now I can now fully answer the question how Linux systems actually store username and passwords, especially password hashes. So I'm going to go to my home directory. So there's nothing in my home directory, but I'm going to make a copy of both files. Sudo copy /etc/passwd. I'm going to make a copy of it on my home directory. Sudo copy /etc shadow. And now I got a copy of both the password and shadow file. Also, I want to make a permission change as well too. I don't want these two copies to be owned by root. I want them change owner to be pi. I want to actually be owned by me, the current logged in user. Okay. So now it's not just root, so I can do like more password. So So let me do this again. More PASSWD. The password file will only have username and then an X next to it, and then the home directory and default login shell. But let's actually now clear the screen and now more of the shadow file. This is the one of real concern. Now I see oblivioner, colon, and then this big long mess here, followed by a bunch of numbers. So now the question is, what does all this mean? What does $6 and then followed by yada yada yada, followed by another $, followed by this big long junket? Now let me teach you how to read a shadow file, or the format of that Linux system, how they store your passwords. Understanding the /etc shadow file. I like this one. I found this a couple of years ago, which is great. There are several schemes for different authentication schemes that we can use on Linux system. The most commonly used and standard scheme to perform authentication against the /etc/PASSWD and /etc/shadow files. The shadow file, which contains one entry per line, each representing a user account. You can view the yada 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 yada. So now here is the interesting thing. This is the username. Obvious. But what comes after the first colon is this $6 yada yada yada. That's the encrypted password. Now here's how you read the encrypted password. It's right here. The password, okay, is using the $type $salt $hashed format. $type is the method cryptographic hash function and can have the following values. $1 is MD5. $2A is blowfish. $2Y is EKS blowfish. $5 is SHA-256, and $6 is SHA-512. Modern, now newer system within the last couple of years have been using $Y, which is called YesCrypt, but it's been interesting to use that on password crackers. Don't worry about that, yes, it's necessary. If the password field contains an asterisk or an exclamation point, the user will not be able to log into the system using password authentication. Okay, so now you know. But let's go back to this example. So now let's take a look at oblivioner and akalabib and magnolia _flower. Let's take a look. So all three of your accounts are $6. That means my current system that I'm logged into is using SHA-512 as the cryptographic hash algorithm. Then, let's use oblivioner. This is your hash. This is your password salt. And that's your full password. So akalabib, that is your password salt that I highlighted after the $, and that is your password hash. That's your full password hash. One more. Magnolia _flower. $6. That's your password salt. And that's your full hash password. Yeah. Okay. That being said, it's now my pleasure to introduce you this semester's password cracking competition. Yes, a password cracking competition for this year is publicly available. Is $, a good question, Vibbs? Is $, never used as a character? I have never, in the hash functions. No, you can. Why are they storing the salt? Because what happened is, when you do your login, that one I can answer. Why they're storing the salt is because, well, we gotta know the salt because whatever you type in, we append your salt to it, so we have to know your salt in order to, append it to the end of your password. Then you do the calculations. So you have to store the salt because if you don't know the salt, then you really, really have to guess things up. So, so the SHA-512 hash output can have special characters and case sensitive. Yeah, that can do so. Yeah. SHA-512 hash output can have special characters and case sensitivities. Yeah. Like you have to store the salt in order to do like authentication purposes. Then, I mean, if you don't, then you have to do like all kind of weird guessing, and then it takes forever. So the fall 2022 password cracking competition is, well, here you go. 16 hashes, two sets, $1 and $6. Uh, Submit often, early and often as possible. Keep records of what you crack. It's going to take you days. You're never going to crack them. Oh, yes. If you crack all 16, you get an automatic A for the class. You don't want to crack all the full thing, everything at once. Break it down by hash algorithm, and there's the explanation of the other rules. So now, what's the biggest question that you got? The biggest question that we got next is, how do we crack the password? I haven't forgotten, who was it that asked the question, why do you have to use like, who was it? I think it was Geo. Geo, why is it usually recommended to require to have numbers, special characters, uppercase letters, and passwords all hash? Well, we'll get to that today. Yep, we'll get to that about now. So, what we're going to do now, we're going to crack the 3 accounts. We're going to crack the password Oblivioner. What do you think your password is? A color beer. What do you think your password is? Magnolia _flower. What do you think your password is? So how do you crack the passwords? Well, now it's my pleasure to introduce you to John the Ripper. John the Ripper! It's a free password cracking tool. Here's the Wikipedia definition. John the Ripper has been around for years. It's a password cracking tool, free, open source. Originally developed for Unix system, originally used by system administrator to audit weak passwords on system. So, unfortunately, password cracking can be used for both good and bad. For good, is like if you're a system administrator and you want to see who is using weak password, because that will be like the most easiest entry point into any system or infrastructure. You use a tool like John the Ripper to audit every user's. Of course, the bad news is you can also use John the Ripper for bad reasons, such as if you want to crack someone's password. The website is openwall.john, openwall.com/John. Okay? Free and open source, okay? Now, because I'm still on my Linux system, how you actually install John the Ripper on like Linux, you can either compile from source, download the source from John the Ripper, from openwall.com/John, or you can use perhaps a little older version is sudo apt install John. So you can either try to compile this by source, or you just do like a package manager. Like if you're on a Linux system, like Raspbian for Raspberry Pi, Ubuntu, Kali Linux, you can use sudo space apt space install space John. Here you do man John. John is a tool to find weak passwords on your system. How you run John the Ripper is really simple. It's John followed by the password file, but it's a caveat though. To use John, you must need to supply it a password file and the desired option. If no mode is specified, John will try single first, then wordless, and finally incremental. But you just can't do this. If you do, on my system, if you do John Shadow, this isn't going to work. This isn't going to work. It could be that simple, but no. Because what you need to do before you run John is what you have to do called unshadow. John the Ripper includes a tool called unshadow. Man unshadow. What unshadow is, it combines both the PASSWD file and the shadow files. Okay? The unshadow tool combines the password and shadow files so John can use them. You might need this since if you only use your pass shadow file to yada 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 yada. How do you actually run unshadow is simple. Unshadow. Okay, hold on. I'll get to homebrew in a bit. Unshadow, PASSWD, and then the shadow file. Okay, let me just clear the screen so I just make it very clear. Currently in my home directory, I have PASSWD and shadow, copy of them. So what I do is this. Unshadow, password, shadow. And that's it. But wait a minute, wait. This is all spit out to the terminal. But what I really want to do is, okay, let's do this again. But this time, I want to actually output everything to a text file. And then what John the Ripper can, then I can use this crackme.txt file, send it to John the Ripper. Now, all I want to do is I want to open up vim crackme.txt. And I don't want to crack, I don't care about these accounts, which have a star as a, for the hash. No, I'm not going to give you my password. I need that out too. We want to only crack the 3 of them. Oblivioner, Akalabib, and Magnolia Flower. So we got 3 hashes. I'm going to save this. So if I do more crackme.txt right now, anyone taking bets here what Oblivioner, Akalabib, and Magnolia underscore Flower actual password were? Okay. So what I want to do now is actually I'm going to do something. I'm going to quit out. I'm going to quit out. Not poop 3. What's your obsession with poop? I have no comments on ZipFlyer 1. So I'm going to CD into my desktop, but I'm actually going to make a copy of crackme.txt on my Mac. There we go. More crackme.txt, because I don't want to be doing password cracking on a measly Raspberry Pi, which has plus is my ad server at home. I don't want to be killing that. Here we go. Crackme.txt is here. All right. So, and done. Can you install? Yeah. How you install John the Ripper on Homebrew is this. Brew. If you use Homebrew on Mac OS, it's brew install John that jumbo. Yeah. You have to add the jumbo in here. Yeah. Why is it brew jumbo? Yeah, it's a customized version of John the Ripper, but this was the one that works. Here it is. John-Jumbo is the enhanced version of John, Unix cracker, yada, yada, yada. All right, Drew Fisher, go Jumbos. Okay. Are you ready? Are you ready, folks? We're now going to run John the Ripper on the crackme.txt file. We're going to crack the 3 accounts. Just before we start cracking, it's a friendly reminder of who we're cracking. Oblivioner, Akalabib, and Magnolia underscore Flower. You're using, we're cracking these 3 accounts. So now I have John installed, so just John crackme.txt. There were 3 password hashes with 3 different salts. This could take forever. Oh no. This is not looking good. No, that's not it, Sam. This is not good. Alright, if I don't get anything in 10 seconds, then I have to quit out. Control C to abort. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, this is not good. We got one. We got a collar bib. We got a collar bib. A collar bib. Oh shit, we got Oblivion there too. Shit, that was quick. That's not good. Okay, so it's actually better than I thought. So a collar bib, your password is password 1, and Oblivioner, your password is dragon. So we haven't cracked Magnolia Flowers one yet. Alright, so a collar bib, your password was password 1. Found me out. And Oblivioner, you're a dragon. Yeah. Hold on, we're not done yet. I want to start from scratch. Now, if you actually are wondering where your password part of all the cracked passwords are stored, on your home directory, there is a hidden folder called .john. There is john.log, john.pot, and john.rec. Here is your pot. We found dragon and we found something. Okay, so I'm going to actually go back. I'm going to start from scratch. Hold on. I want to go back to that John folder here. I'm going to do an RM start. I want to start from the beginning. I'll go back to my desktop again. So, okay. If you just run straight John without any username and password, remember how John actually works. Let me go back into the Pi-hole and look at the man page for John. To use John, you need to specify a password file. We did that, and its desired option. If no mode is specified, John will try single crack first and wordless mode, then finally incremental. Ideally, you always want to use wordless mode. Wordless mode can crack password pretty damn fast. Where can you get wordless from? I want to introduce to you to my friend Daniel Meisler. Daniel Meisler has a project called SecList. I always have a copy of SecList on my computer. Pi-hole is my what they called ad blocker at my house. SecList is free and open source. It is the security tester's companion. It is a collection of multiple types of lists used during security assessments, collected in one place. List types include username, password, URL, sensitive data, fuzzing payload, data patterns, and all that. And of course, SecList is just a security tester's companion. I want to give a shout out to Daniel Meisler for this. I had a copy of SecList for years. Here's a list of all the passwords. Here's a whole bunch of password lists here. There's a whole bunch of password lists. How about this 500 worst passwords.txt? There you go. Yeah, you don't want to be using these as a password. Shoot, I should have had Diablo as a password. Whole bunch of password lists. 10 million, there's a 10 million password. There is a Twitter band. Ooh, here's a whole bunch of Twitter band passwords. Seasons. What's season.txt? I don't know. Ooh, look at that. Spring, summer, autumn. Yeah. Dutch password list. Cool. Dark web. Ooh, top 100 and all that. All right. Clarkson University. It's a whole bunch of password lists. Well, anyway, I actually have a copy of, even better, I have a copy of SecList on my computer. I'm back on my Mac now. How about this one? Exact CryptoNet 10 million passwords. How about that one? Yeah. Look at all that. Look at all that. That password people have used for years, my friends. Let's do a word count. How many lists are there? Are there 10 million? No, there's only 5 million on here. What the hell? How about this one? Dark web. How about dark code? How many lines? How many words are there in dark code? Quite a bit. Word count, dark code, 1,471,056. Okay. All right. How about this one? Dark web top 100. Here, your top 100 from. Yeah, here you go. So here's what you do. So use word list mode. Shoot, I should have had, make a copy of that little path. How you do word list mode is this. John minus word list equals the full path to your word list, top 100, crackme.txt. Watch what happens. You ready? So ideally when you crack password, your best friend is always using word list. So if I do John minus word list equal John space minus word list equals, well, the word list, and then the crack me file, watch what happens. Boom. Crack 2 of them just like that. Remember, if I actually go back to my hidden .john folder, remember I cleared this out? More john.log. There you go. More john.pot. And I found Oblivioners and yeah, and Dragon. Yeah. But hold on. We haven't cracked Magnolia underscore flower yet. I'll let you do that. I know what the password is, but I'll let you crack it. I'm gonna post this on I'm gonna actually post a hash for Magnolia flower. So we cracked Oblivioner just like that, and a Calabib password just like that using wordless. Really quick. Now to a Geo's question. Why do you want to use complexity such as special characters and all that stuff? The hell is it? Here it is. Data is beautiful, my friend. I like this one. This is one of my favorite Reddit posts. I have a lot of favorite Reddit posts. Time to crack your password. Time it takes to crack a password. So here's a number of characters for a password. 4, 5, 6, 7, 8, 9 to 18. If you're only using numbers only, if you're using the letters, lowercase letters only, if you're using a mixture of uppercase and upper and lowercase letters only, if you're using numbers, uppercase and lowercase letters, what happens if you're using special symbols? So as you can see, if your password is really short, like 4 or 5 characters, your password will be cracked instantly. If you actually have a really cracked password, a really short password, and you're using numbers, uppercase, and lowercase letters, it's going to be cracked just like that, can be cracked just like that. But as you can see, when you use numbers, uppercase, and lowercase letters, and also symbols like the @ symbol, you know, the complexity of your password takes a lot longer to crack the password. I can, sure. Well, yeah. Here's the thing. But Geo, here's the thing. No matter how long or complicated your password is, no matter how long or complicated your password is, it will be broken. Your password will always be broken, given given a matter of time. Everyone's password will be cracked, given a matter of time. It doesn't matter if it's 1 second, 1 minute, 1 hour, 1 month, 1 week, 1 year, 1 century, 1 millennia, doesn't matter. It's all just a matter of time. Okay? It's just going to be a matter of time. And the problem is there's so many hacked databases out there, so many systems that got breached. That doesn't help as well. One last thing. Before I go, I know we're running a little bit out of time. I want to introduce to you if you actually are curious what accounts that you have that may have been hacked, I want to introduce you to haveibeenpwndd.com. Haveibeenowned.com. I want to give a shout out to Troy Hunt. Yeah, Troy. Yeah, it's my party now. Quite. Yeah, Royce, just to let you know, there's a reason why in my password cracking competition, if you crack all the password hashes, you get an automatic A for the class. So yeah, if your password is "it's my party and I'll cry if I want to," isn't gonna take a yeah, yeah, yeah. There's also a reason why that yeah, it's an automatic A. So yeah, Royce is correct on that one. Have I been owned? Going back here, have I been owned? PWNED. Check your email or phone if in a data breach. Now, Troy Hunt is the creator of HaveIBeenOwned.com, and I can assure you that he does not store any imports to this field like email or phone. Yeah, I mean, here's the largest breaches that have been around. It's like insane. So all you need to do is just enter your your email address, and see if you've been owned. Oh no. mchow@cs.tough.edu. That's my work email address. That's been in breaches that I've been owned in. I don't know what the hell that is. LinkedIn. Oh, fuckers. Vacation.io. I've been scraped. Oh no. Oh no. Oh well. ming.chow@tough.edu. Yeah, basically these days it's now getting harder and harder to be in the green. Yeah, that's also been in a breach as well. I don't know what the hell Apollo is. I don't know what the hell that thing is. I don't know what the hell that thing is. Yeah, so if you want to check, how does people calculate the time to crack? Like, is it based on home? Yeah, that's a good question. Yeah, I mean, ideally, look, if you're going to be cracking password for a living, yes, that's a thing. Um, you want to be using like GPUs. I hear the price of GPUs are now getting cheaper because actually, if they find people are figuring out that mining cryptocurrency is not worth it anymore. Yeah, so they actually use like things like GPUs for cracking. Yeah. So that's it, folks. I think I did quite enough today. So now we have done today hash function. The wrong way to store passwords. Password salting. How Linux systems stored password hashes. John the Ripper. Password cracking. Wordless. Yeah. Oh yes. And have I been owned as HIBP? Many of those have mashups of data. Yes. Um, dude, this is awesome. And checklist. And also, you got a bonus of data is beautiful, time that it takes for a hacker to crack the password, and have I been owned? It's a long one today. Really want to thank you all for like staying with me, for staying here. Really special thanks to Royce, the Tycho Tithonus for joining in today. Really means a lot. Royce is actually a professional in the not only the information the cybersecurity community, but also you do a lot of work with password cracking. Thank you so much for being here. Means a lot to me. Have a great weekend, everyone, and see you next Thursday. Bye now.